Okay, a second way to look at this is the interquartile range. Now, the reason the range can be somewhat misleading is sometimes those really large or really low values are really unlikely to happen. And so if I'm talking about the range in general, I mean the range of all possibilities. What people are usually interested in, though, is the range of likely probabilities or likely outcomes, right? So forget about those things that hardly ever happen, right? Somebody wins the lottery, but it's probably not going to happen in your lifetime. Just about everyone loses money when they play the lottery. Um, so if we take away those extremes on both sides, we can look at, well, what's the likely range? And what the interquartile range does is it looks at what is the range of that middle 50%. So if I take away the top 25% of possible outcomes, I take away the bottom 25% of possible outcomes, what does that range of the middle look like? So if I look at this, right, I have these numbers here, 1 through 6, these numbers 1 through 55. These numbers in B are exactly like A, except for this 6 is a 55. When I look at the ranges, right, I see that this range is gigantic. Almost 11 times as big as the range of A. Now, it's only because of one data point. And right, I could make this out of 100 values, and I could just have this one, and the two sets of data would be perfectly identical, except there'd be just one data point that's different, and then it makes the range look completely different. And so when we have outliers, these unusual events, we try to do something that gets rid of those effects. So if we split the data into quartiles, what I'm doing there is really splitting it into quarters. So I'm going to take the top 25%, the second 25%, third 25%, and the fourth 25%. And I'm going to kind of cut my data accordingly. Now the boundary between those quarters, or those fourths of the data set, represent my quartiles. So when I look at my first quartile, it is that boundary between the first 25% and the second 25%. The second quartile is actually the same thing as the median, and it represents the boundary between the second quarter and the third quarter. The third quartile represents the boundary between the third quarter and the fourth quarter, and then the fourth quartile is just at the top. Now, the things that we're interested in are the third and the first, right? The boundaries that get rid of the top 25% and bottom 25%. What are those values? Now, the way that we typically do this is we find the median. So to find the first quartile, I take the first half of the data and I find the median value of that data. In this case, because it's even, right, I have a 3 and a 3. I would add them together, divide by 2, just like we find the median, and I get my value of 3. For the third quartile, right, I have a 5 and a 5. Add them together, divide by 2, I get another 5. So in this case, my interquartile range is going to be 2, which is 5 minus 3. If I look at my second data set, right, even with that 55 in there, it has no impact on what the third quartile and the first quartile are. My interquartile range, and again the range between the inner quartiles, as we want to call them, is still only 2, even though I have that outlier kind of mucking things up. If I just pretend that those things aren't there, right, I get a better, clear vision of it, right? 3 to 5, hey, that's a range of 2. 3 to 5, that's a range of 2. But because it's not the range of the whole data set, I'm calling it the interquartile range. We can do this the same way in Excel by highlighting and using the right formulas. So basically what I'm going to do is I'm going to say I want to look at something that equals the third quartile minus the first quartile. Exactly what we did here, right? And if we look at our data itself, right? What I'm doing here is I'm typing in this equation right here, equals quartile. I highlight my range of data. I identify which quartile I'm talking about. So this represents what part of the data I'm looking at. This represents which quartile I want to specify. And then I do the same thing, noting that I'm highlighting the same data here, only I'm looking at the first quartile. So it's the third quartile minus the first quartile. I hit enter and I get my value here. And I can do that then, again, drag it across and get those values for everything else. And as we see, if I want to zoom in a little bit here, that the interquartile range of basketball players is actually quite small. Even though the range was the biggest, the interquartile range is tiny. In other words, the middle people make like nothing. That middle 50% of all people, the range of possibilities is very, very small. For artists, there is substantial variability. And if we look at accountants, we find that their range is also very small, right? That I get a very, if I'm kind of average, I'm going to get a very consistent experience relative to my peers who are closest to me in ability, in situation, in access, whatever. So I can make a better prediction about what my likely outcomes are going to be. And I do that, again, by getting rid of those extreme values by just looking at that middle range. And so you can think of it as like the middle 50%. Out of those people, what's the likely range of possible values?